Welcome back, class. I am Dr. April Ström, and I have another video for you of another product rule example. Now, one thing to be reminded of is the product rule itself, which once again says if you are multiplying two functions together and you need to take its derivative, we will then write the derivative as the first function's derivative times the second function as is, plus the first function times the derivative of the second function. Okay, quick review on that. But you might check out the function that I have here. K of x is equal to e to the x divided by x to the fifth, and say to yourself, well, we don't have a product here. Well, actually we do. Watch what happens. Now, I will say most students, they don't really like fractions or things that are written as ratios, and so there's a big propensity to actually rewrite this function as a product, and we can do that. So let's see. What you need to notice is that my denominator happens to be x to the fifth. It has a power. What I can do is just bring that whole function up to the top, to the numerator alongside the e to the x. But when I do that, I need to negate the power here, make it a -5 when I switch it around. So I'm gonna just write here, right below this, I'm gonna say, or we could write this function as k of x is equal to the e to the x that we already had multiplied by x to the -5 power. These two functions mean exactly the same. They just look different. They're just formatted different. But by rewriting, I can now actually invoke the product rule to carry this one forward. So once again, just take note the kind of functions that we have in each of the pieces of this larger k of x function. We have an e to the x, so that's an exponential function. Once again, the exponent is the thing that's changing. The variable x is in the exponent, therefore an exponential function. Whereas over here, we just have a -5 in the power. It's a constant number. The power is not changing. Thus, we have a power function. So let's get busy on finding the derivative of k of x. So we have k prime of x is equal to, now I want to say, still label this as my setup. I'm not actually going to find the derivative of the pieces. I love doing my setup, and then I will report what the actual final derivative is. So per the product rule, we need to take the derivative of the first function, so e to the x. We're going to find its derivative in a moment. We are going to now multiply by the second function, so times x to the -5 power. We will then add to that the first function as is, e to the x, and then we will multiply by the second function's derivative, so x to the -5 derivative. So you can see I haven't actually taken the derivative of all the pieces, I've just put it in the product rule form. So now, carry this one forward, we have k prime of x is equal to, well, this is my most favorite function in all the world. When I take the derivative of e to the x, it turns out it's just e to the x. So e to the x's derivative is e to the x multiplied by this x to the -5. Well, that just gets copied down. Nothing to do there. Plus e to the x again multiplied by the derivative of that second function. Once again, a reminder, this happens to be a power function, and then just be careful with the -5 as the power. So when we go to find this derivative using the power rule, once again, we'll bring that -5 down in front, and then we will reduce that power by 1. So just a quick note, if I have -5, subtract 1, I now have a new power of -6. So I'm subtracting 1 from that -5, thus I get a -6. Now notice carefully, I put this particular term that I got from that derivative in parentheses. Imagine for a moment that I didn't. So let me just erase this. This is a common mistake that comes up all the time in Calculus 1. Imagine I didn't put the parentheses here. What does that actually look like? If I don't have parentheses, it seems that we would take our e to the x and subtract off this other term, but that's not what we are doing. In fact, we are multiplying. So we have to indicate that with the parentheses to share with the world that we intend to multiply. Now, I recognize that this equation that we have is in fact the derivative all done. If in the event that you need to simplify, you certainly can. Some instructors do ask that you simplify further, but I think it's just fine as is. There's no additional simplification absolutely required unless you gotta do some other things maybe to this equation, which you'll learn a little bit later in the calculus course. So I'll leave this one right here as a final answer for the derivative of k of x. And I'll just say, if you like this video, please make sure that you like the video and subscribe to our channel. And also I want to mention, in a later video, if you're interested, I will take the derivative of k of x in its original form using the quotient rule so that you can compare and contrast. Thanks.